Every substance has some magnetic properties associated with it. Based on these magnetic properties, substances are classified into 5 categories. They are paramagnetic substances, diamagnetic substances, ferromagnetic substances, antiferromagnetic substances, and ferrimagnetic substances. Before understanding about these classifications, let us try to understand how these substances exhibit magnetic properties, or what causes these substances to show magnetic behavior. The origin of the magnetic properties in the substances lies in the electrons. Each electron in an atom behaves like a small tiny magnet, and these electrons move around the nucleus. It is called as orbital motion. And also the electron spins around its own axis, and these two types of motion generates magnetic moment in the substance. Electron being a charged particle and undergoing these motions, it can be considered as a small loop of current which possesses a magnetic moment, and therefore each electron has a permanent spin and an orbital magnetic momentum that is associated with it. The magnitude of this magnetic moment is very small and is measured in the unit called as Bohr magneton. And we have 1 Bohr magneton is equal to 9.27 into 10 to the power minus 24 amps per meter square. Now let us discuss the classification of substances based on these magnetic properties. The first classification we are going to discuss is paramagnetism. The paramagnetic substances are weakly attracted by a magnetic field. They are magnetized in a magnetic field in the same direction. When the magnetic field is removed, the magnetism is lost by the paramagnetism substances. The paramagnetism is due to the presence of one or more than one unpaired electrons in the substances, and these electrons are attracted by the magnetic field. The examples for paramagnetic substances are oxygen, copper 2+, iron 3+, chromium 3+. The second type is diamagnetism. Diamagnetic substances are weakly repelled by a magnetic field. Examples are water, sodium chloride, and benzene. They are weakly magnetized in a magnetic field in the opposite direction. Diamagnetism is shown by those substances in which the electrons are paired and there is no unpaired electrons in the substances. Pairing of electrons cancels their magnetic moments and they lose their magnetic character. A few substances like iron, cobalt, nickel, gadolinium and chromium oxide are attracted very strongly by a magnetic field. Such substances are called as ferromagnetic substances, and these substances can be permanently magnetized. In the solid state, the metal ions of the ferromagnetic substances are grouped together into small regions, and these regions are called as domains. Each domain here acts as a tiny magnet. In an unmagnetized piece of ferromagnetic substances, all these domains are randomly oriented and their magnetic moments get cancelled. When these substances are placed in a magnetic field, all these domains get oriented in the direction of the magnetic field, and a strong magnetic effect is produced because of this orientation. Now, this ordering of domains persists even when the magnetic field is removed, and these ferromagnetic substances become a permanent magnet. Certain substances has domain structure that is similar to that of ferromagnetic substances, but their domains are oppositely oriented and cancels out each other's magnetic moment, and these substances are known as antiferromagnetic substances. Example is manganese oxide. Ferrimagnetism is observed when the magnetic moments of the domains in the substance are aligned in parallel and anti-parallel direction in unequal numbers, as you can see that from the figure. They are weakly attracted by the magnetic field as compared to that of ferromagnetic substances. Magnetite as well as ferrites are the examples of antiferromagnetic substances. These substances also lose ferrimagnetism on heating and they become paramagnetic in nature.